Good evening all. Today we will discuss question number 2. So what is the question given means check the injectivity and surjectivity of the following functions. So function f equal to first what is given, the function f equal to function from natural numbers to natural numbers. Here f of x equal to x square is the given function. This function we have to check the injectivity and surjectivity. Injectivity and surjectivity means which is 1 and onto. So first before that we have to check the arrow diagram. See the arrow diagram, both also natural numbers. So I can start with 1 2 3 4 like that. Here 1 2 3 4 etc 9 16 like that. So it is a n square function from a natural number to natural number. F of x equal to x square. So 1 is mapped with 1, 2 is mapped with 4, 3 is mapped with 9, 4 is mapped with 16. Clear? This is the arrow diagram. So from the diagram we can say that it is 1 1 and on 2. See that it is first checking 1 1. So when it is 1 1 or not, clearly we can say it is 1 1 because every number has unique image in natural numbers. For example, 1's image is 1, 2's image is 4, 3's image is 9, 4's image is 16. No two numbers having same image. So clearly 1 1. We how to prove that? Let x1 comma x2 belongs to the natural numbers if f of x1 equal to f of x2. I need to prove that x1 equal to x2. So what is the f of x1 value? F of x1 equal to x1 square. What is f of x2 value? That is equal to x2 square. Taking square root means we will get plus or minus x1, similarly plus or minus x2. Here x1 and x2 are both natural numbers, so only possibility is x1 equal to x2. So I have taken f of x1 equal to f of x2. I proved that x1 equal to x2. So clearly I can say f is 1 1. What about onto? Check that onto means what? All the elements of y in natural number should be an image of some element of x. See that clearly 2, 3, similarly 5, 6, these elements left unmapped. If I want to map 2 means I need to take square root of 2, because square root of 2 making square means that will be mapped with 2, but this square root of 2 does not belongs to the natural number. So clearly this element is left unmapped. So what I can say, this is not onto. So I am going to prove that it is not onto. How I am going to prove means it is clear that example you can take a 2 belongs to natural numbers. There does not exist any element x belongs to natural number. This 2 belongs to second set, this x belongs to the first set. There is no element, which means there does not exist any element x belongs to n such that f of x is mapping with 2, since root 2 does not belongs to the natural number set. So clearly I can say f is not onto. F is not onto. Clear? So now what about the question number 2? Second question. This is first question, second one first subdivision. Second subdivision, what is given? Same function is given, but the domain and codomain is different. Domain is integer, codomain also integer. So domain and codomains are integer means we will draw the arrow diagram now. So the arrow diagram is, it is integers, it is also an integer set. So I can take 3 numbers alone, -1, 0, 1, 2. -1 taking here also it will come -1, 0, 1, 2, 3, 4 like that. So -1 is mapped with 1, 0 is mapped with 0, 1 is mapped with 1, 2 is mapped with 4. So here it is 1 1 or not. Clearly we can say minus 1 and 1 having same image. So it is not 1 1. Similarly minus 1, 2, 3 are left unmapped. Clear? So it is not on 2. Right? 1 1 proof now. So we know that clearly it is not 1 1. So see that I am going to prove it is not 1 1. Clearly I can take any two elements, either minus 1 plus 1 or 2 minus 2 or 3 minus 3, any element here. So see that now minus 1 comma 1 belongs to the integer set. Clear? Minus 1 and 1 belongs to the integer set. Here f of x1, that is what, f of minus 1. F of minus 1 equal to, here the given function f of x equal to same function previous questions, x square. So minus 1 square is plus 1. Similarly what is f of x2? F of x2 is f of 1, that is also equal to 1. So what I can say, f of 1 equal to f of minus 1, which is equal to 1, but 1 not equal to minus 1, that is f of x1 equal to f of x2, but x1 not equal to x2. So clearly I can say f is not 1 1. F is not 1 1. What about onto proof? Already I said it is not onto because the elements minus 1, 2, 3 are left unmapped. There is no element in x having 2 as image. There is no element in x having 3 as image, minus 1 as image, minus 2 as image, like that. So I can say that it is not onto. So onto proof I will write now. What is onto proof? It is clear that I can say same element 2 belongs to natural numbers, that such natural number set there does not exist any element x belongs to natural number such that same f of x equal to 2, because root 2 does not belongs to natural number set. As previous problem, if I want to map this 2 means I need to take root 2 here, then only it will map with 2, because root 2 square equal to 2. Clearly we can say root 2 is not a natural number. So I can say that f is not on 2. So the previous case f is 1 1 but not on 2. Here f is neither 1 1 nor on 2. Clear? See the next question. Question number 3. Here different domain is given. What is the domain? Means f is a function from real numbers to real numbers defined by f of x equal to same x square. Clear? So this function is 1 1 or 1 1 or not, we are going to prove. So real number set. Real numbers means all the fractions will come, root also will come. See that it is real number, it is also real number. Same minus 1, 1, 2, 3. For example, one more is a rational number. So we can real numbers, we can take one more rational number also. Similarly, I can take here minus 1. Start with minus 2, minus 1, 0. 1, 0 also you can add here, so add 0 also in real numbers also. So now 0 1 added, next 2 I can add 3 4, like that I can add 1 by 4, like that. Real numbers at many numbers it is available. So now map with 1 is mapped with clearly 1, minus 1 also mapped with 1, because 1 square is 1, minus 1 square also 1, 0 square is 0, 2 square equal to 4 I can map with, 3 square is 9, so I can add one more element, 3 is mapped with 9, 1 by 2 square is 1 by 4. So here also see that only one example is enough to prove that it is not 1 1. The same example 1 and minus 1 in the real number set, the 1 and minus 1 both also having 1 as same image. So I can say that it is not 1 1. Clear? What about on 2? Here also minus 1 minus 2 left unmapped because these 2 and 3 are mapped because 3 is mapped with root 3. If I am taking root 3 means root 3 is a real number, 3 is mapped. Similarly 2 means if I'm adding here root 2, if I'm adding here root 3 means root 2 is mapped with 2, root 3 is mapped with 3. Clear? But negative numbers are left unmapped because square root of negative number, I need to take square root of negative number minus root 2 minus 2 root 2, that is root of minus 2, sorry, root of minus 2 I am taking means whose square equal to minus 2, that only it will map. But my root of minus 2 is a complex number. This number does not belongs to real number set, so clearly it is not onto. Now I am write the 1 1 proof and onto proof. 1 1, what about 1 1? Same, minus 1 comma 1 belongs to real numbers. F of minus 1 equal to 1, f of 1 equal to 1, f of minus 1 equal to f of 1, but minus 1 not equal to 1. Clear? So I can say f is not 1 1. F is not 1 1. What about onto? Already I said it is not onto. I am writing the proof. Onto. It is clear that minus 2 belongs to the real number set. There does not exist any element, x in the real number set. This real number is second set, this real number is first set. There does not exist x belongs to R such that f of x equal to minus 2, because root of minus 2 does not belongs to the real number set. Root of minus 2 does not belongs to the real number set. So I can say f is not onto. Clear? So one more question, fourth question. This is 3 questions are having same functions. Here different function we will take. F is a function from natural numbers to natural numbers again. Here f of x is given that x cube, f of x is given that x cube given. Okay, so what is the real domain here? Domain is natural number, codomain is also natural number. So natural number 1 2 3, it is enough. 1 cube 1, so I am taking 1, I am not taking 2 3. Okay, I am adding 8 also, 27 also. So 1 cube equal to 1, 2 cube equal to 8, 3 cube equal to 27. So clearly I can find every natural numbers cube that I can map with here. But what about 2 3, these numbers are left unmapped. So it is 1 1 because the images are distinct, elements have distinct images, images are distinct. That is, 1 has only one image, 2 has only one image, 3 has only one image. So it is clearly 1 1. What about onto? It is not onto because 2 3, these elements left unmapped. If I want to map 2 means I need to take here cube root of 2, because cube root of 2 making cube means I can map 2. So this cube root of 2 is not available in the natural number set. So clearly I can say that it is not onto. So I will prove 1 1 now. I will prove 1 1. What about 1 1? I can take let x1 comma x2 belongs to the natural number set if f of x1 equal to f of x2. Here f of x1 value is x1 cube, f of x2 value is x2 cube. I can factorize this x1 minus x2 whole cube equal to 0. If I am factorizing means I can write that x1 minus x2 into x1 square plus x1 x2 plus x2 square equal to 0. This second the second polynomial is not equal to 0, because if we are factorizing means we will get complex numbers. It is not possible because we are dealing only in natural numbers. So only possibility is x1 minus x2 equal to 0. This implies x1 equal to x2. So I have taken f of x1 equal to f of x2. I got x1 equal to x2. So I can say that f is 1 1. Clear? What about onto? I already said it is not onto. So why it is not onto mean this 2 left hand mapped, 3 left hand mapped, similarly 4 5 6. Okay, that I am going to prove now. So onto. So already said how to write onto proof. It is clear. It is clear that 2 belongs to what set we have taken? Natural number set. 2 belongs to natural number. There does not exist any element. There does not exist any element x in the natural number set. This natural number set is codomain. This natural number set is domain. Clear? So x belongs to natural number such that f of x equal to 2, because cube root of 2 is not available in the natural number system. So clearly I can say that f is not on 2. Clear? So one more problem is there. That question number 5. F is a function from integers to integers. The function is same, f of x equal to x cube. Clear? So I am taking integers now. Integer domain and integer codomain. Integers. So integers means negative numbers also will come. -1, 0, 1, 2. Similarly here also -1, 0, 1, 2, 8, like that. So -1 cube is -1, 0 cube is 0, 1 cube is +1, 2 cube is 8. So what we can consider here, it is we can say that every number have one unique image. Every element of x have unique image in y. So I can say that this is 1 1. What about on 2? Here also the numbers 2, 3, 4 left hand mapped. So it is clearly it is not on 2 as previous problem. Clear? So how to write the 1 1 proof now? So if 1 1 I am writing here. If x1 comma x2 belongs to integers, what is f of x1? F of x1 equal to x1 cube, f of x2 equal to x2 cube. So f of x1 equal to f of x2. If I am taking f of x1 equal to f of x2, x1 value is x1 cube, x2 value is x2 cube. This implies like as previous problem, x1 equal to x2. So therefore f is 1 1. What about onto? As I said, it is not onto because 2, 3 these elements are left hand mapped. So I can write this. It is clear that 2 in integers there does not 2 in integer there does not exist any element x belongs to the integer. This integer is codomain, this integer is domain. So x belongs to z such that f of x equal to 2, because since cube root of 2 does not belongs to integers also. Clear? So I can say that f is not on 2. Clear? F is not on 2. Clear? So we have seen 5 problems today. All the 5 problems are not getting not on 2. Not on 2 means it is not surjective. Clear? So that is I told only 1 1 and on 2. But question is given that 1 1 means injective. 1 1 means injective. onto means surjective. In previous video we have seen that what is injective, what is surjective, what is definition of one, what is onto. Similarly, so injectivity and surjectivity, so all the problems we have put only surjective, not surjective. In previous upcoming problems, problem 3 4 very interesting problems are upcoming. So these problems we will prove, some problems it is onto, some problem it is not onto, we will see clear. In next video we will see the problems 3 4 and 5. Thank you all.